I'm Christine Loughlin, and I will be showing you a behind-the-scenes look at the marine research infrastructures we are preparing to deploy on a one-week research cruise called AIMSIR. Now, a bit about me. I'm from Boston, Massachusetts, and I studied environmental science at the University of Vermont before moving to Galway, Ireland, where I did my master's in marine and coastal environments at NUIG. I'm an early career professional working as a scientific and technical officer at the Marine Institute, which is Ireland's national marine research agency, and encompasses various aspects of sustainable development of the marine environment, from research in marine biology to mapping Ireland's seabed to conducting oceanographic observations. My team in the Marine Research Infrastructure section maintains the operation of key marine research infrastructures here at the Marine Institute. On June 1st, we will be on board the RV Celtic Explorer, a 66-meter research vessel steaming towards our first location on the AIMSIR cruise. Now, AIMSIR stands for Atlantic In Situ Marine Scientific Infrastructure Replacement Cruise, or AIMSIR for short, which translates to weather in Irish. Like all functioning instruments, marine infrastructures need to be maintained and serviced regularly, checked to make sure their sensors are working properly, and replaced if necessary. In order to do that, we need to take a vessel to the infrastructures that are already there, recover them, and redeploy new versions of them. These instruments play a critical role in meeting our Ocean Decade challenges for ocean observation and open data sharing. I am here at the Marine Institute, and I will be taking a really quick tour of a few of the instruments we will be deploying on the AIMSIR cruise in 2 weeks' time. Right now, they are in the yard being built out. Let's go and check it out. As the name of the cruise may suggest, our priority infrastructure we will be recovering and redeploying is a weather buoy. This particular platform is called M6 and will be about 220 miles west of Galway at the Rockall Trough. Here, you can see the bottom half of the buoy that sits in the ocean. The rope to anchor the buoy will run through the center, along with a wave logger for measuring wave height and a CTD sensor that monitors sea temperature and salinity. The top half of the buoy holds 2 sets of atmospheric sensors in case any fail while at sea. These sensors monitor approaching weather systems and improve forecasts by transmitting near real-time information via satellites. In the coming days, the top will be bolted to the bottom portion, making the buoy over 6 meters tall and weigh over 5 tons. The M6 buoy is part of a 20-year-old network of 5 offshore data buoys that is operated by the Marine Institute and Met Éireann, Ireland's national meteorological station. These buoys are important to maintain in working order as they are a key ocean observation system, providing crucial data for weather forecasting, risk management for shipping, and advanced warnings for coastal villages. The network also provides a long-term data set of oceanographic data in Ireland's deep waters and is open access to the public. Now, let's take a look at the deep-sea mooring that will be located near the M6 buoy at the Rockall Trough. This mooring will be anchored with a 2,500-meter mooring line. Attached to this will be 1 subsurface buoy at 500 meters and 7 CTD sensors from 750 meters to 3,000 meters to test the water column for sea temperature and salinity. These deep-sea observations are important as there are several water masses that flow through Rockall Trough. The data from this mooring gives scientists insight on the ocean circulation in the Northeast Atlantic. The Rockall mooring is part of EMSO-ERIC, which is a European collaboration of research infrastructures working together towards a common goal of exploring the oceans by sharing ocean observation facilities and information. Finally, we will be deploying a few Argo floats on this cruise. These floats are deployed from the vessel, where they will drift along the current at 1,000 meters for 10 days before descending to 2,000 meters. On its descent to the sea surface, the float will take CTD measurements which will be transmitted via satellite. This cycle is repeated until the float runs out of battery, usually in about 4 to 5 years. As a member of Euro Argo, Ireland has a commitment to launch 3 floats each year and regularly collaborates with other countries to help fulfill their quotas, as we will be doing on the AIMSIR cruise. The Euro Argo floats make up 25% of global Argo network, providing a long-term dataset for scientists to monitor the ocean climate and can be useful in creating accurate ocean models for predictions. Data from the Argo floats are accessible to the public on the Argo website. So, all there's left to do is pack my bags and hope I find my sea legs quickly. I'd like to thank VCOMS for the opportunity to share with you all an insight on marine research infrastructures and how they provide us a platform for ocean observation to predict changes in our ocean, forecast weather for a safer ocean, and how we share this data.